Thank you.
We're all fun. Yeah.
I tried to learn Japanese.
Rio tenki desu ne.
Oh yes, today it is very beautiful. Okay, we'll just do that. Okay, behind the table. As you can imagine, this is the size of one of the cameras. This elevator, so that we can move things up. And the weight limit is 3.5 tons or 8,000 pounds.
Well, the good thing you got us at the beginning of the cruise and not the end.
Yes. Yeah. I think we are.
We're okay here.
And you're going to see this beautiful telescope.
Yes.
How many floors up?
Okay, so please stay here for the time being.
Okay.
Forget which kind of telescope. Is this a segmented telescope?
No, this is a single mirror.
I'm going to explain that.
Yeah, it's the largest one in the world.
Katie, you guys are going to visit Keck Gallery after this, or not?
I'm sorry?
Are you going to visit Keck Telescopes Gallery?
If we have time.
Oh,
Yes.
okay, okay. Yeah, that would be great. Yes. Okay, so let me go through. Now this building, the elevator tower is fixed to the ground. Now you step onto this side. This side of the building rotates with the telescope. So therefore there is this little green box there, watching that these two buildings are facing to each other in such a way that you don't fly. Okay, please.
Just like this.
The tube in the UK and mine the gap.
When you say chasing, actually it's chasing the sky object, the speed of the rotating.
Yeah, this part of the building rotates as the telescope spins to follow the star. I will explain that later on.
Yeah.
Okay.
Beautiful weather, less wind, which is great for you.
Good weather today.
Yes. You brought this. You brought this good weather, and you bring this weather with you for the eclipse.
I'm excited. I haven't even seen the telescope. This one is.
Now you start looking right?
佢裏邊等於外邊嘛，佢打開望遠鏡係啊，等於出邊嗰啲天氣嚟㗎。
佢裏邊凍到出邊啊！佢唔知係咪佢個路要凍啲㗎？
唔使嘅，不過佢食通。
會唔會太陽曬住？
係啊，梗係啦啲。
哦，呢個。
Oh yeah. Please watch your step. There's a gap.
Okay.
Or can be slippery or whatever.
It sounds
No.
like squirrels living in there.
Okay, yeah. What do you hear?
Squirrels.
This is the cryogenics to keep the detectors cold. What do you feel? The air.
Cold.
Yes.
Cold.
This is to keep this environment as close to the nighttime temperature as possible, which is close to the freezing point. What do you see in front of you? A massive steel structure, right?
Right.
You don't see the mirror because it's encased in a cover or container. During the daytime, our primary mirror, 8.2 meters in aperture, usable diameter, is encased to avoid dust accumulation. Also, more controlled air conditioning. You may want to use the key strap. Okay. This one is a single piece mirror. 8.2 in the diameter is number 3, third largest. number 1 and number 2 are in the mainland USA. This is number 3. And the segmented mirror, the representative of that segmented mirror, highly advanced technology, is in our neighbor, to our next door neighbor. Yeah. Keck. Twin telescope. There are 2 telescopes. And there is going to be, hopefully in the very near future, a bigger one, segmented mirror below this side.
That's the 30-meter telescope?
Yes, that's what.
Yeah.
Touch wood,
Yeah,
anything that I can. Okay, now you are standing the enclosure side of the building. I'm standing the telescope side of the floor. And somebody noticed that there is this gap. This side of the telescope, which is 555 pounds, spins on its own. Then this building needs to spin with the telescope as well. So that this shutter, through this shutter, which opens left and right at night, the telescope can see the sky through or with this opening. You okay? And whatever that okay? If that's convenient for you, okay? Yeah. Well, by the way, up here the air is clean, much less pollution, so you may feel better. I have such a cool, member that he says up here is much better. Okay, even if it's thin, the air is thin. Okay, now this one, Subaru telescope has to serve a variety of themes of the research, because this is an open-use, common use telescope for not only for the Japanese researchers, but all for the all astronomers in the world. Anybody can put a proposal. We call for the proposals twice a year. Anybody can put, but it has to be in English. And each one of those proposals get 5 referees, international referees. Referees. And get ratings from those astronomers. Right. Then according to the points, the research group may get time or may not. And it is usually 1 to 2 nights. And that's enough to write a research paper. Therefore, like this year, there are about 100 research papers published.
Is it ever cloudy so they don't...
There can be some nights. Yeah, there are some nights
right.
Cloudy, no data, or snow, no data.
Seiko, how oversubscribed is the telescope?
It's not that big as Hubble.
Yeah.
4 times.
4 times. So they receive requests for 4 times as many nights to observe as they can accommodate. It's very competitive. Obviously, when you have one of the world's largest telescopes, everybody wants to use it.
What kind of research can they do during the bright run near the full moon?
Okay, infrared.
Okay. Oh.
Yeah, because moon is not bright in infrared. Especially up here, we can do not only the near infrared, 1 to 5 microns, but also, 5 to 10 microns, so-called mid-infrared, 10 microns, 20 microns. So that's very, very interesting.
The atmosphere has certain wavelengths that are transparent to the infrared. It's not continuous like daylight. So there's, in the wavelengths she's talking about, there's a band and opening, mostly due to carbon dioxide and water vapor, especially water vapor at 10 microns of wavelength and 20 microns. So at those wavelengths, you can see out into the infrared universe pretty well. Glenn Orton, a good friend of mine, was just here.
Yeah. And there's a web release based on his research.
Yes.
Okay.
So you can do that on the moon? And was that the question?
Yes.
At the moon? Okay.
Yeah, yeah, Okay, so probably you can imagine that at dark nights, optical people come, and bright nights, infrared. Good.
I have infrared camera here. Near infrared.
Yeah.
So I heard there's infrared sky glow just from the atmosphere.
Yes,
I
that
haven't
is
seen it with my camera.
okay. You may suffer from the so-called air glow.
Yeah.
Airglow, yes.
Yeah, that is OH radical.
Yeah.
So the imaging part of the infrared observations, they have filters. For
Yeah.
the spectroscopy, well, don't have to worry about that much. Okay.
Oh, I see. So they filter that.
Green laser occasionally there.
Yeah, there's a green laser occasionally.
Somebody's fooling.
Oh yeah. The other group using the laser pointer.
Laser pointer.
Yes. Okay, so why don't I use mine as well? Okay, so let's move back so that I can show you. Okay, because of that demand for variety of the observations, this telescope has four different focal stations. One, obviously, the Cassegrain at the bottom of the telescope. Two, behind these black walls, Nasmith focus or foresight, and one at the top. And because the top portion is, well, technically challenging to have big instrument at the top of the telescope, this is quite unique. I believe only LBT, Large Binocular Telescope, in the mainland has the top unit capability. Okay, so if you can trace this green point there,
Yeah.
today we have this secondary mirror for the infrared observations. Then the Cassegrain focus we have multi-object infrared camera and spectrograph. It's a bit boring name. But multi-object, it can take like up to 50 objects for the spectroscopic observations. Now, I said this is an infrared secondary. Okay, this is a luxurious telescope. We have three different secondary mirrors and three top unit, meaning this system can go at the top of the telescope for the wide field of view observations. Three secondary mirrors, two are for the optical observations, therefore they have aluminum coating. This one for the infrared, because of the higher reflectivity, this is silver coated mirror. So look at that color.
Very nice, very nice. Is it covered with anything?
No, bare silver. Because the air is so clean here, the silver does not tarnish. If you are one of those people who use silver, real silverware, you have to, polish it quite so. No need up here. As you can see, it's been like 2-3 years since we did coating, applied fresh coating on this secondary, and it's still shining. So that's special this mountain is. Okay, less oxygen, less moisture, much less pollution.
So it's very, very dry here.
It is. Like, you might be suffering from this dryness here. Yes.
On the lips.
Yeah. Okay, then others are secondary mirrors. Now, the top unit, it's very special for Subaru telescope. Wide field of view observations. And that's very convenient to look for interesting objects or farthest objects in the sky. However, taking pictures do not guarantee that whatever you are looking at is the furthest. Then it is important to have something to back it up. That one over there is the spectrograph that measured, or has been measuring the distance of those things in the sky.
And you move that into the Cassegrain position, you swap them back and forth.
Yes, and that yellow dolly thing is the robot to exchange, that we use to exchange the Cassegrain instrument.
How long is the changeover time? From when?
Just one daytime.
Just during the daytime. So you could
3
do
hours.
Okay.
3 hours.
So this detaches and they roll it over here and
Yes, yeah, yes. And as I mentioned, these instruments, they can come up here using the elevator that we just used. 2 tons. Each weighs 2 tons. That one is 2 tons. And it's like 2 meter, 2 meter, 2 meter, or almost 7 feet each dimension. It has to be within that dimension. And the center of gravity has to be in the middle. So that this 2-ton category instrument does not interfere with 555-ton telescope's drive. Yeah.
Is it made of steel? Or?
Yeah, inside these covers, yes, there is a sturdy structure. The surface that you are looking at is the cover for the thermal insulation applied on top of that steel structure. So you may not think that the structure is sturdy, but you are looking at only the skin surface.
Sheet aluminum or something?
Oh, yeah, just aluminum.
Nice color.
Thank you very much.
Yeah, it's your baby.
Yeah, okay, now why it's blue? Do you know why it's called Subaru telescope?
Ladies?
What's the color of those stars?
Blue stars. Blue stars.
Young, massive blue stars. Hence this color.
Okay.
But this is very special. This one has less reflectivity in the optical, while in the infrared it does not interfere too much. Okay, the same character as the stealth bomber's surface. Okay, you cannot catch those airplanes either in the optical camera nor in the infrared camera. This does not interfere with optical and infrared. This blue paint, very special paint. We had a choice of colors, but you know, when somebody says that's the color of silver stars, then it has to be blue.
So it's dark in the colors you care about.
Yeah.
It's black
Yeah.
as far as the detectors are concerned.
Yes.
It's all about scattered light.
Yeah.
Yeah.
The
Minimize.
bearings on the changing the altitude of the telescope this way.
Okay.
Or
yes.
yeah.
You see that we call sector?
Does it float on mercury?
No.
No.
Oil.
Oil.
Mercury.
Pressurized oil.
Yeah, pressurized oil. And these two sectors, as you can see, the motors are linear motor, so it does not. There is no friction to begin with. Then it's sitting on this thinner film of oil. These bearings, so it's oil bearing. Therefore, it is very smooth. If you can push this telescope with your hand, if you can reach. Oh yeah, yeah. And likewise, the spinning, the azimuthal axis, the same thing. So during the shop assembly, we did prove that we can do it. So the telescope was balanced and they were able to move by just pushing.
Do the detectors rotate to counteract the self-resonance?
Yeah, the detector, there is an instrument rotator. Okay, so let's go downstairs and change the station.
So all the big telescope use the fog mount, outer semi fog mount, and then you have a big derotator to compensate for all those.
You can imagine that these cable runs out for that. This meant derotator according to the position of the telescope. This part rotates. So the stellar image on the CD detector stays the same. Okay, thank you very much. And we are going to the next station.
Saiko, what is the focal ratio? Is it 1.8?
For the propane, yes.
Yeah,
And this one is around 12.5.
oh yeah.
Very fast online.
影緊嘅我錄緊嘅，你幫我跟住佢落去講。
我哋跟住嚟啊。
So this is the driving.
Yeah, I guess so. I guess.
So like home here. So that's the way the detector.
Okay, take some snaps and we have the next group waiting for us.
Okay.
Over here than it is outside. And there's an interesting story behind that. When we first started observations in the telescope, the heating was horrible. The air was always
Bye. Sorry.
We need to go.
We need to 行啦，人哋等緊喺部 lift 度。Okay.
You come back here?
No.
Hard to leave.
Don't want to split your group here.
行啦，
So,
睇住
they finally figured out what the problem was that the temperature of the
Okay.
was different than the temperature of night air.
Thank you.
Was faster than the air. Flight field of wide
F ratio.
Okay. Plus F ratio
Fast
is
F ratio.
yes. Yeah. Actually, the top limit is F2.
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 Head count.
That's pretty good.
2, 4, 6, 8, 10, 11. Good.
The 11 includes
You know, I'd hate to have to leave you here and help the astronomers overnight.
What a hard trip that would be. Fun to try. I don't know how to get back. Gonna pick up the ship when? You have to chase it for 6 days.
着緊㗎，我睇住有條罅搭過去。So I'm going to take it. 喂，點樣熄㗎？ Then we go up. 使唔使熄㗎？
We need to get the elevator going.
Yes, okay. So the F ratio for the top unit, the proportion is F2. Then the Cassian is around 12. Nasmith is around.
Seiko, before you press that, we're now this group server. There's a beautiful view of Keck right between that. So do we have time to let people take a quick picture?
No. Yep.
Yes. Okay.
Yep.
So right where to your left there are the two Keck domes. You can't all go one, but just run right up and take a snapshot. You'll want to have that shot.
Yeah.
Yeah. Thank you.
Don't worry about that. Okay. It's saying by the way, you know when I. 喂，撳邊個掣啊？撳咗佢先。
唔使嘅，由得佢，佢夠咗去影嘅，唔好停。
睇下影住你啦。
So you've been here a long time.
嗱，我影住你啦，唉，我哋都影。
Oh wow! Oh, so and do you have a doctorate in astronomy or?
Yes. My background is in
What type?
Oh well,
Doctorate.
哇！
All of a sudden I feel
哇，好靚！
Subaru.
影完呢邊影嗰邊啦，都嘅呢邊，不過就冇望遠鏡呢邊。
You got used to it now.
Oh yes.
As long as you're not trying to
fresh air.
Yeah.
In the meantime, I know
Is that nice picture?
Yeah.
Before I forget, so here's my card. That's okay.
唉，影下你個床。
That's okay. That's all right. Most women that have Kelly are
小嘅，你哋呢部機影唔影到相㗎？
唔好影相啊！
唔好影啊！你自己影啦，你自己影啊！快啲啊！
Okay, back to the elevator.
快啲！
Thanks, Kelly. That was a good idea. I don't often see these.
快啲啊！喂，等緊啊！哦。啊！呢邊影唔影啊？嗱，呢邊影多幅走人啦。
That is a shot. Wow.
一幅咋？
Nice.
你行翻後嚟。
degree is international. However, most of my I have been with a big telescopic project, including the commissioning or designing,
Cool.
and it's been fun.
Yeah, that's cool.
It's been fun.
So that's an
Nice.
engineering.
Thank you very much.
That's really an engineering.
Nice shot. Nice shot. I did.
It's
Woo.
just a prime, because you're up. You can't get it
The
anymore.
lighting is so
Okay,
nice.
Look at this.
Just perfect.
Now talking about the
You know
fast
what I
focal
have-
ratio.
You know, with the film,
Okay.
you
If
wait a couple
to
weeks to see.
camera has to have a good
Nice.
corrector.
Oh, yeah.
Anybody using a polarizing filter?
I do.
Yeah.
Ah, good.
Oh yeah, you have to have it. Okay. Now the fast focal ratio has to have a good corrector lens.
Yes.
Imagine which company made built the corrector for the wide field view camera.
Oh, for the wide field camera. You mean the corrective optics?
Yeah.
Co-star, you mean?
Yeah, corrector.
I don't know who. It's a test.
What, the first telescope with the
I failed.
No. I'm talking about the optical corrector for the wide field of view camera.
Nikon.
Okay. Let me close the door. Otherwise,
Is this an adaptive optics telescope?
I don't know. Really good question.
and as you can imagine, two of the famous industries, optical companies contributed to many aspects of the telescope. But the recent very conspicuous is the wide field corrector for the hyper supreme cam.
Right.
Okay, supreme cam. It's already super in its name. Supreme cam. Not a pizza. That can capture one full mode in a frame, which is very unique for an 8-meter telescope. Now the hyper supreme. Pretty soon they will run out of this kind of prefix. Hyper supreme cam can capture 9 full modes.
9 full months, right.
But it's a challenge. The corrector is this big,
Aha.
the diameter.
Are we going to see that?
Sorry, no, but you can
It's up at one of the Naismith cosine, or?
this is the topic.
Okay.
Rồi跟住我啊你，跟住佢錄佢。唔係啊，你睇住有揼啊！
So that we can keep the size of the gadgets that we use. So behind you is the tower that they use. Yeah, put it to assemble the lens system, the correctors.
This.
Yeah.
Was it? All right.
And you can see the name of the company. Okay?
Oh,
Canon.
not Takahashi.
Yeah, okay. You know, no distortion at the edge of your field of view, wide field of view. Okay? Canon is very good at it. Then Nikon, the fine resolution.
Canon 做㗎呢個嘢，呢個鏡。
And we are fortunate to be able to utilize those expertise. Okay? So here, imagine a big truck comes in from this door, the shutter. Big truck. Okay? Use your imagination. Goes back to history. This one opens up. The hatch above you opens. The ceiling crane comes down to pick up this 20-ton mirror from the truck bed.
20-ton.
Yeah. Single piece.
Oh, so that's the level we were at.
No, that's there's another level above it, but
That was about the same amount of tonnage as the Palomar mirror before it was ground down.
20 tons.
19 and a half.
Yeah,
This one's much, much bigger.
much bigger
But
and
it's
much
thinner.
much thinner. It's about 8 inches. This
that's
one.
on.
This
Only.
thing.
Does it have adaptive optics?
Active optics, which is the support 261 actuators, real-time change. You know, not only the elevation but also the wind load. Okay, the wind pushes the mirror, then the actuators compensate for that deformation.
So that
not
is-
fast, but we do have adaptive optics. Yeah, and that's for the atmospheric turbulence.
Right.
And we have this probably this big deformable mirror. This small, so it's easier to control.
Right.
Okay. Yeah, 20 ton, 8.2 meter, 1 hertz compensation. I don't think so. No.
So you can actively use the telescope in the wind
Yes, to some extent.
to some extent.
Because well, other part of the telescope is not that sturdy. So there can be wind shear.
So the active optics support the primary and maintain its figure. Right. The adaptive optics is a separate system.
Not the secondary. Not
Transfer them?
yeah. After tertiary.
After the tertiary.
Yeah, again, so that then the sensor, both the sensor and the deformable mirror can be small. Now, here is the thing that you can feel almost feel the scale of the mirror.
Right. See the plastic up there, that gives you a sense of the size of it. Is this where you silver it, illuminize it?
Well, this is the gear to pick up the glass part of the mirror system. And then the mirror goes to that station for the wash.
Washing?
Removal of the coating.
Yes.
Then in front we use the chamber.
Right.
We use conventional technique. Vaporized aluminum or silver to
Right.
apply the coating on the mirror.
How often do you do that?
Oh, once in 3-4 years. Because of our structure, it takes 1 whole month.
1 month.
So 1 month shutdown versus
Right.
30 mirror.
Right.
There is
Right.
a trade-off.
Right.
However, in order to operate the telescope 366 nights this year,
This year?
no break, we cannot do upgrade or maintenance that require more than 1 day. Okay, no shutdown due to the maintenance. Therefore, okay, by the third year, there are things that we need to do, which require significant downtime. So that's again a trade-off between the maintenance versus night time.
Right. And when you do go down for maintenance, you try to take care of everything so that you...
Makes sense.
Yeah, it's just crazy. Somewhere between 30 to 60 people all over the place.
Wow.
So they have to be brought in.
Yeah, some, yeah.
How do you lift the mirror and move it over?
Yeah, that is a great question. Okay, here you see the jig.
Oh.
Big,
Okay.
heavy.
Oh, this is it.
The glass part sits on the mirror cell. The mirror cell has,
Attach points?
yeah, lift point.
Yeah,
Lift
lift
point.
points.
Yeah, then using this one and the wire here.
Little wire.
A little wire, yeah.
And in order to attach this one to the crane hook, we have another crane. I don't think even my big guys, can lift this.
Yeah.
So that's the scale.
Impressive. Watch your heads as you go underneath.
Yeah, quite technology.
Yeah, so there's a reason that I just need to.
Right.
Yeah, please.
This is crane.
係啊，呢個 crane
Take those deep breaths every now and then.
睇住個頭啊。
And you can imagine, okay, this one, the yellow part comes down
Okay.
and comes out. And you can imagine what kind of music you'd like to put on your YouTube video, if at all. Okay, this one comes down and comes out. And this one is holding the glass part of the mirror. Okay, it's like scissors.
Yes. Scissors.
Yeah.
Yes.
Yeah.
I know. Right. Got it.
Yeah. Okay. Then this one lowers the mirror onto this lower part of the chamber. Then we do the removal.
最近睇住睇住，係 真係。
No, she said they come underneath it like scissors, like
crab legs.
Yes.
Like crab legs.
Yeah, from the side and underneath.
Oh, I see.
Yeah, see
Yeah,
the
so it's
C,
like-
they're like the big C clamps all around the edge.
Yeah, and the cylinders are to, the footage.
Touch the floor?
Yeah, no, the mirror cell.
Oh,
Yeah.
to lift it off the cell.
Yeah.
So it comes right off the cell and moves over.
And this one goes out to receive the mirror. Then, okay, once there is nothing above those actuators, people come in to take care of the actuators part. So again, many people, many cars.
Right. So when you're when you're illuminizing the mirror, is when it's the only time you have to get at the actuators to repair them.
Oh, wow.
The top portion of the actuator. Okay, so this is like a spaceship. Flipped. Oh, flipped. Outside is atmospheric pressure. Inside is vacuum. Okay, spaceship flipped.
Like the backward station.
How do you do the alignment of the optics?
Optics, that is a very good question. Okay.
Yeah, but that's later after you do all this stuff.
Yeah, but the mirror, the primary mirror has pockets on the back of those mirrors, at the mirror, where the actuators go up. Okay. These 261 actuators have to be exactly where they are supposed to be. Otherwise, they cannot go into those pockets.
Right.
That's the most scary part. Okay, imagine your mirror with those sorry, this is a Hawaiian word. Holes on the back of the mirror.
Yeah.
Right.
The actuator needs to go into that.
Yes.
And there is no way that you can squeeze yourself in to realign the actuators. So they have to be there. So that part of alignment is very scary. So before the mirror comes back, they check the location of those
So you have to
actuators.
bang on it with your fist a few times to get them to go.
It's always like that. Yeah.
To get it to slide in right.
You have pneumatic control of the whole structure of the fog mount underneath the platform.
The actuators are motors, not pneumatic, not passive. They are all active.
Electric.
Yeah, there are sensors. Well, each actuator has sensor and measuring the force on those actuators, and then they act accordingly, or according to the command that they send from the computer. So this again, this is the chamber. Well, the vacuum coating chamber. Yeah, that's one. By the way, this one, the company which made this chamber was based in Boston, but actual fabrication took place in Seattle, probably near the Corning, no, Boeing. Sorry, Corning is the glass company.
Yeah. Right. Which is the company in Boston?
Process systems.
Because I live near Boston.
Yeah, okay. And this one is vacuum expert. Provided the tunnels for the colliders, super colliders, gravitational wave experiments.
So this is why you need
Watch your
This
heads.
is why you need
睇頭。
Look. The size of these.
縮低啲個頭，你高啊，縮低啲。再縮低啲，跟住再wear 你嗰隻腳啊。係，OK，繼續，呢邊你挨住右邊行，係。OK，呢邊。
Vacuum system.
Wow.
睇住樓梯啊！睇住。你跟住我行啊！
All right, the Meade telescope was used to measure the scene. Again, the tower for the assembly of one of those cameras.
Very nice of you to take time to do this for us.
Oh, well.
Catherine, yours haven't been seriously damaged. So I shouldn't even ask the question, right? All right, you never heard me ask the question.
Well, as you can imagine, whenever we work around the primary mirror, we are very careful. Extremely careful. And probably not everybody can have access to it. I
You
don't
keep
think.
the scientists away, correct?
I know that.
They're the accident prone.
The question about the hydrosynchronic camera. I read 470 megapixels.
I don't think so because there's this 2K by 4K.
Okay. Chip. That's 8 there. That would only be 60 chips. If you have 2K by 4K, that's 8 megapixels. Right?
The number is 116 or 120
Chips.
chips.
Okay. And if each chip is
2K by 4K.
so if each chip is 8 megs,
That's what all that.
Chip is 8 megapixels.
So 800 megs.
800 megs. More than 470. 800.
Come on. Yeah, and it's gigantic.
Yeah. It's huge.
Yeah, the filter is like this. I have to use my both hands to show the size.
Ready, wave.
It's enormous.
Count.
You can find your way out.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
We're going up or down?
Although they consider a 9% loss acceptable.
Who considers that? That would be one of us.
9% of 11.
That's one.
Barrier between the detectors and the rest of the air.
Oops, sorry.
Oh yes,
Sorry.
yeah. The detector for the vacuum and cold temperature, they are in the thermos, shall I say.
I noticed this big, look like insulated cylinder.
Yes, yes.
No, I thought I would just have to tough it out.
Okay, so you know the drill.
In making
You can open that door and you can go back in. But stay in that spare room.
I'm dressed.
Are we good opening his door here? Are we opening?
Yeah, yeah, you can open the door.
Yeah, open the door and
有個 gap 啊，好似頭先我有個 gap。哦，again。
Another one.
This is the rotating.
啊，呢個又高啲啊啦，呢個。
Let's move in. So that
Alright,
moves
let's move in.
yeah,
啊？啊嗱，你睇頭啊。
the base.
Yeah, same view.
Right. No. by Japanese or experience.
呢度， come on, this way.
Ship canceled.
Yeah. Weight-wise, I'm sure we can fit.
Okay.
Okay, so I'm saying.
4, 8, 11. Okay.
Okay, Japanese subway.
With a guy to push you in.
Yeah.
All breathing units
Yeah.
now.
Where are we going now?
To the deck that you can see the entire structure of the telescope. That's the last stop for this group.
The grand finale is
We look down to see the main mirror from the top.
Maybe it's good.
Good. Kelly, if you can move along this.
Okay, let's go to the left.
Yeah, and then.
And right. This way. Follow the guy in the red coat. Good?
Freezing.
You're videotaping continuously?
Yes. It's my
Good
job.
tour.
I'll do all the editing afterward.
That's right. Here she comes.
Okay, yeah, right. Don't use the stairs.
睇住位好行啊！
Okay.
跟住喐落佢講嘅嘢。
嗱，你搭住我膊頭啊！
Go ahead.
Okay, I'm sorry.
Okay, make sure that all your belongings are stable, secured. Okay. All right, here we go.
Okay. Turn left.
Turn left.
Maybe hold the door. Yeah, I hold the door.
Yeah. Okay. One after.
仲有跟住行啦。
Yeah.
Hold the door.
睇住。
Okay, let me stand here, go all the way to the edge, so that they have a better, clear view of the telescope.
Okay,
because
okay.
of this scaffolding.
Okay.
Okay, please come this side, so that the scaffolding does not block your view. Right? Okay, you came at the time that this big thing is going on. Look up. And if you
Okay.
can see that yellow arm of whole structure, can you see it?
Yes.
Yes.
That is the exchange system for the top unit. Okay, that arm can hold the secondary mirror.
Which weighs how much, the secondary?
Secondary mirror at the top of the telescope?
That weighs how much? How weighs how much?
This one, that one is the lightest, 1.5 tons.
Oh,
But
okay.
Hyper Supreme is 3.5 tons. So it's not that easy for the human beings to take care of that without the help of the robot.
The notion of a 3.5-ton camera suspended over your 8-meter primary is just scary to me.
Yeah.
It is. But therefore, it is very important this robot works perfectly.
Yes.
So this is a part of the, well, to ensure that this one works. So there's this scaffolding from all the way from the floor to the top, so that they can work on it.
Yes.
So this is a very special phase. Okay, it's part of the preparation of the commissioning of the Hyper Supreme camera with 800 million pixels. My brain is not working properly. I know that. At least I know that. Okay? So this Hyper Supreme camera will be commissioned pretty soon, I hope. And what it can do? First time for this telescope to be able to capture Subaru Pleiades.
Oh, the entire Pleiades.
And that I'm begging the commissioning the instrument group, take a picture.
Right, as your first light.
Oh,
Yeah,
it
you
should
know,
be. The
people call it crazy. You know, 8 to 10 meter class telescope. Usually they are after the high spatial resolution or you know, detailed structures, and they don't take the wide field of view pictures. Therefore, first time on this telescope. Well, so please, from time to time, look up in our website.
Yes, of course.
Maybe it'll be NGC 253.
Oh, that's easy.
Yeah.
That's easy.
Do you want to say anything about the coolant incident?
Yeah. Well,
I was.
Yeah, because you know, we have this top unit, wide field of view camera. In order to maintain its performance and also remove the extra heat from that system, there is this water cooling system. Water cooling, closed circuit. Okay, there was an incident that this hose, the plumbing broke. And underneath this instrument, what is there?
What's underneath?
What's underneath?
Let's have a guess. They had a
Up
problem.
on the secondary, you have water leaking on the primary in here?
Bingo!
Yeah.
It was not a good day at Subaru.
No. No.
It was a leak. You have to stop the condensation?
It wasn't condensation, it was a whole leak.
Yeah.
No.
Like probably 30 gallons.
Was it distilled water?
It's
Antifreeze. So it had
the pink one.
Yeah.
The pink one.
It wasn't just water.
Yeah.
No.
I didn't think it could be unless it's under pressure.
No, it's coolant. Okay. Therefore, we had to water wash it. Water wash. And also the instruments were the electronics does not agree with any
They were
form of-
incompatible.
So let's carry this to completion. You have this water falling on a curved mirror. The water flows to the center, and what's in the middle of the
drain it
to the Cassegrain hole into the instruments that was underneath.
So
Is it
two
pure
instruments. No, it does not matter pure or not. Well, it was sticky by the way, so it was kind of. But two instruments and one primary mirror was kind of out of commission for some time. Primary mirror, we were able to put it back for usable condition in 2 weeks.
2 weeks.
2 weeks.
Yes,
You just had to wash it.
yeah, water wash.
One question, because Canon, the photography equipment company from Japan, they mentioned that the focusing system, lens system of this telescope was made by them, you know, this focusing system before the light hit the CCD. Is that correct? Yeah? Because
probably,
they have the picture showing
probably
us.
you're talking about this optical corrector lens in front of the CCD. Yes. Yeah. So that this wide field of view, if the image is distorted across this focal plane, it does not help much. Okay, it has to be flat. You know what I mean?
Yeah.
Right.
So,
Because the focal plane is naturally curved,
yeah.
and you need to correct it because your detector array is flat.
Yeah.
How big's the image circle?
The focal plane for this hyper-superior camera is, as I say, I have to use this
Much bigger than the 14-inch square.
That's right.
So your
It's
detector,
almost symmetrical.
your megapixels is this big? Your detector
Yeah,
is-
the 800 megapixels.
Right, that's right.
So imagine, in order to insert the filter, the structure, the mechanical structure is humongous.
The thickness of any filter do affects the focus.
Yeah,
Absolute
there
focus
is
of
a
the
real
image.
compensating. So that part is no problem. So
There wasn't just one lens. It was they
Yeah,
had,
they have
Was
to
that
have.
made in Japan?
I don't think
I
so.
think that was made at Caltech and JPL.
Yeah.
Coast. It was something called CoStar. I'd have to look that up.
Yeah, no, it's static. So that part is good. Anyways, as you can see, you see the secondary mirror today, but it can be the primary focus unit.
And you said that's the infrared secondary?
Yeah, you can tell because it does not have the baffle.
Ah.
Baffle meaning room temperature structure, which emits thermal radiation.
Oh, of course,
Right.
of course,
That was
sure.
Yeah, so it does not have that.
How long it takes before you start imaging to make the indoor temperature?
Oh, for this building,
Yeah,
it's
to go equivalent
nothing.
to the outside.
It's nothing. Because as I said, the temperature that you feel, this cold temperature, is almost close to the nighttime temperature. So during the preparation of the observation, they open up this
The
door,
door, okay.
shutter, and the side doors, and let
I see.
the air flow.
I see.
The natural air conditioning takes care of the initial flushing and the equalization.
So we're going back this way?
Yes.
Okay.
Okay, let me read the
Just.
我呢個多
係啊，佢話開㗎。出去啦。轉彎行啦。咩？行啦，safe 㗎。
I have a Takahashi telescope at home.
Oh,
Yeah.
I have one.
Oh, you do?
Yeah. Oh, that's great chicken skin.
Yeah.
I love it.
I have the.
Wait. This is not supposed to do that. Again, Japanese subway.
11?
Okay. All present and accounted for.
Yeah.
Yes,
You know how these things are. Mind your small.
Did you notice that there's this thermal insulation?
Yeah.
Ugly stuff.
Yes.
Yeah,
It's
okay.
not asbestos.
No.
Oh, no, they
That's
use that for 30,
spray
40
kind
years.
thing.
Spray foam.
Yeah, well, thermal insulation or removal of the heat, active removal of the heat. Okay.
We're here.
So our electricity bill is huge. This island, well, there's no natural resources big enough to accommodate all the power requirement. So they, really rely on oil.
行啦，冇事啊，冇事啊。你又影嘢啊？好啦
Have a generator here?
That's emergency. That's for
好啦，呢邊呢邊。
Oh, so where does, you said
The
there was...
power comes all the way from the sea level Did you see the power poles along the saddle road, access road? That's how we get the power.
So there's a power plant down there.
And UPS batteries and emergency power generators, that's for the emergency. We shut down the telescope and retrieve.
I wonder, their electrical generation for the city of Hilo, is it natural gas?
Mostly oil, imported.
Fuel oil. Yeah.
That's why there is a push for natural, sustainable, such as geothermal, solar, wind, ocean.
Tide, yeah.
The temperature difference.
Oh, okay.
The surface it's warm, tropical, and then deep down. This island is not on the shelf of the continent. 100 feet out, it's deep down. So there is a big difference in the temperature of the ocean. So they are using that temperature difference to create power, and also there is a byproduct.
Oh, they are doing that already?
Yes.
Oh, cool.
West side. The byproduct using the cold water.
Air conditioning.
Main lobster.
Main lobsters.
You can drop them.
Nice.
I love it.
So now we know why Red Lobster gets its supplies.
Yeah, yeah, in this island.
Yeah.
The best kind of.
As you know, you're from Boston. Lobsters are so cheap around Boston, they're cheaper than steak. $4 a pound.
Sometimes.
$5.
Send some over here.
Yeah. Okay, then as I said, geothermal it's serious business.
Yeah.
A quarter of the power supply here is on that.
Okay.
All right. So,
thank you so very, very, very much. This has been
It was a great tour. Arigato gozaimasu. So we take off the hats.
oh yeah, those are not souvenirs.
The helmets are not souvenirs,
No.
but these are souvenirs. Everyone, please take one packet.
Looks like there's no. Where did the hat?
Just leave on the floor.
Okay.
We have to call for extra.
Oh, thank you. Oh, thank you.
Yeah.
It was an excellent tour.
Wondering.
Oh, wow. Thank you very much for coming. And I'm sure you will bring this good letter along with you.
Anybody got one?
Everybody have a packet?
Yeah, I have a packet.
Yeah, what?
Marty?
So you're in the same part of the
Okay.
There's clouds below.
Thank you.
Oh, you.
It's a souvenir.
Yes, I think. Yeah, souvenirs.
What part of China are you originally?
Hong Kong.
Hong Kong. Great, great. Nice to see you. Nice to see you.
Again, thank you so much.
Yeah.
Thank you very much.
Thank you very much.
Okay.
Yeah, do we have to?
Your is small. Yeah. You have enough clothes.
Yeah, because you know.
Thank you.
Yep.
Thank you so very much.
Thank you.
This has been wonderful.
Yeah, all right.
I'm Kelly B.
Yeah.
Thank you very much.
Please read our
How about
website.
you take a
Remember,
picture?
Right,
Subaru.
right.
Can we take a picture?
You want me to
Picture
take
with you?
a
Can we
picture,
take a
please?
picture of your...
Cycle? Can I take a picture with phone?
Yeah, I'll take a picture of you.
I'll take a picture of everyone.
You
Here,
can-
here. Easy. I take a picture of
All right,
everyone.
all right.
Yeah, okay.
I'll take the stupid hat off.
Yeah,
Just
Subaru.
press the button. It's all right.
3, 2, 1, 0.
Famous Leica.
Okay.
Great.
Thank you.
Thank you.
Okay, enjoy the rest of your voyage.
Thank you. 行得行得，冇事啊，行得 safe 行啦冇嘢行一直行。
No, of course
喂，係咪撳個掣啊？嚇？誒，
You'll let me know.
係咪就咁撳個掣啊？喂
Come on.
，OK。
But you know, I'll tell you something. Sorry, go. initially it was very difficult to get.
唔係喎，爹哋，你自己睇下。
佢撳一下會。
唔係係咪呢個啊？
上下邊手指公。
啊手指公。